OpenAI has introduced a groundbreaking method to address a common issue in the world of artificial intelligence: errors and hallucinations. These errors can lead to confusion and even potential harm. But OpenAI has come up with a solution. It's called process supervision. Now, let's break this down. Unlike the traditional approach, which only cared about getting the final answer right, process supervision takes a different, more effective route. It rewards AI for each correct reasoning step it takes. This means AI is not just fixated on the end goal. It's learning from its mistakes, thinking more logically, and becoming more transparent. As a result, we can better understand how it reaches its conclusions. To test the effectiveness of process supervision, OpenAI conducted a math problem-solving task. They compared an AI trained in the old way with one trained using process supervision. And guess what? The process-supervised AI outperformed the traditional one. It made fewer mistakes and its solutions were more human-like. Plus, it was less likely to produce hallucinations or false information. This is a significant win for AI accuracy and reliability. In this video, we'll dive into the concept of process supervision, what it means, how it works, and why it's superior to outcome supervision. We'll explore how it enhances mathematical reasoning and reduces AI hallucinations. We'll also discuss the advantages and disadvantages of this new training method and what it could mean for OpenAI and its products in the future. So, be sure to stick around until the end of this video. Let's dive into it. Process supervision is a fresh approach to training AI models. What's unique about it? Well, instead of just rewarding the final answer, it actually rewards every correct step of reasoning. Think of it as giving feedback for each little piece of thinking that leads to a solution or answer. Now, imagine we want to teach an AI model to solve a math problem. We've got two equations, x plus y equals 16 and x minus y equals 4. Our goal is to find the product of x and y. By working through these equations, we discover that x is 10 and y is 6. So when we multiply these, we get the final answer of 60. Each of these steps is spot on according to human logic and math rules, so each step gets a thumbs up from a human supervisor. The final answer, 60, is also correct, and it gets the same positive feedback. Now, let's consider another scenario where we train an AI using outcome supervision. This method only gives feedback based on whether the final answer is right or wrong according to human judgment. It doesn't care about how the AI got to that answer. For instance, if the AI model using outcome supervision came up with the answer that the product of x and y is 40, that's wrong, and a human supervisor would give it negative feedback. But here's the catch. With outcome supervision, we don't know how the model reached this incorrect answer. Did it stumble at a particular step, or was it just making wild guesses? We can't tell because we can't see its thinking process. This is where process supervision shines. It lets us peek into the AI's thinking and reasoning. It allows us to spot and correct its mistakes along the way, guiding it towards the right solution or answer. In essence, it shows us how the AI thinks, making the whole learning process transparent and effective. It's like being able to supervise and mentor the AI every step of the way, and that's the beauty of it. Let's get into it. We're talking about a pretty cool concept here, a reward model that can give feedback for every step of reasoning based on human judgments. Now, a reward model is essentially an AI system that can put a number value, like a reward, on any input. This reward can be good or bad, depending on whether the input is what we want or don't want based on certain human criteria. For example, think of having a reward model that can give feedback for each step when you're solving a math problem. This reward model would give a positive reward, like a +1 for any step that's right according to human logic and math rules. On the flip side, it would hand out a negative reward like -1 for steps that don't quite align with what humans consider correct in math. Now, to train a reward model for assessing reasoning and math problem solving, we kick things off with a dataset. This dataset has math problems, and each one has been looked at by humans. They've rewarded each step of the problem, showing how well it lines up with the right way of thinking. When a step is correct, it gets a positive reward. This includes things like adding, subtracting, multiplying, dividing, or finding a specific variable. With this dataset in hand, we use techniques like gradient descent to teach our reward model. It learns to dish out these reward scores for new examples. It's like we're training it to judge each step in solving problems the way a human would. It's pretty nifty, right? Now, let's dive into something fascinating. ChatGPT Math, an AI model designed to tackle math problems using everyday language. The plan is to train it using process supervision combined with a trusty reward model. Here's how it works. We throw unsolved math problems at ChatGPT Math and it starts breaking them down step by step. Imagine we've got a puzzle where we need to find the product of x and y, given that the sum of x and y is 16, and their difference is 4. ChatGPT Math takes these equations and starts solving them bit by bit. After each step, the reward model comes into play. If ChatGPT Math takes a step that's correct, like adding those given equations, it gets a pat on the back with a positive reward. And, as a bonus, the reward model tosses a hint for the next logical step. ChatGPT Math uses these hints to figure out the next move. This cycle keeps on until the problem is solved, with each correct step earning a reward and a helpful nudge in the right direction. So, here's the magic. ChatGPT Math learns to solve problems in a way that matches human logic and those good old math rules. It's not just about spitting out answers. It shows its work and explains its reasoning in plain language. This makes it transparent and trustworthy, unlike models that merely drop a final answer without any explanation. Now, why does process supervision outshine outcome supervision? Well, it's pretty simple. Watching every step is more effective than just peeking at the final result. It helps boost performance and allows the model to learn from its blunders. If we only focus on the end result, we might miss where it went wrong. Keeping an eye on each step also helps steer clear of mistakes and incorrect data. The model gets feedback at every turn, making sure it stays on track. And watching every step makes the model's thinking crystal clear, earning the trust of the people. Simply looking at the final answer doesn't tell us how it got there. Lastly, monitoring each step nudges the model to think more like a human, aligning its answers with our expectations. Just starting at the final result might lead the model down a path we don't quite agree with. So, process supervision is the way to go for a clearer, more reliable AI. Now, process supervision, as exciting as it is, comes with its own set of challenges that we're working on. It's not all sunshine and rainbows. One issue is that it demands more computing power and time compared to just checking the final answer. Think of it as grading every single step in a math problem, not just the result. This can make it a bit pricier to train those large AI systems we all love. Another hiccup is that this approach might not be the perfect fit for all problems. Some tasks don't have a straightforward thinking path to follow. They might require more creativity than this method allows. That's something to consider. People also wonder if this approach can handle real-world situations where the data isn't flawless, or if the AI model faces brand new, complex challenges. It's a legitimate concern. So, what's on the horizon for this type of AI training? OpenAI has been awesome enough to share a massive dataset packed with human feedback. It's like a treasure trove of human notes for each step when solving various math problems. This can be used to train new models or give existing ones a good checkup. While we can't predict the exact moment when OpenAI will incorporate this into their AI models, based on their track record, it might not be too far off. Just imagine the possibilities. AI that can explain its thought process, solve math problems without errors or bogus information, and lay out its steps in a way that anyone can understand. And it's not just about math. This kind of training could be used for so much more, like crafting summaries, translations, stories, code, and even cracking jokes. It could also help AI models answer questions, fact-check, or construct persuasive arguments. This method has the potential to level up AI quality and reliability by rewarding every correct step, not just the final outcome. It's all about making AI models more transparent, showing their work, and explaining their thought processes. Ultimately, this could lead to AI systems that can communicate with people in a way that's crystal clear and trustworthy. Exciting times ahead! Now, isn't process supervision just fascinating? OpenAI's groundbreaking approach to AI training is like giving these digital minds a mentor to guide them through every step of their thought process. It's all about transparency, accuracy, and reliability. But here's the fun part. We want to hear from you. What do you think about this revolutionary approach to AI training? Do you see it as a game changer for the world of artificial intelligence? Or do you have questions and concerns? Leave your thoughts in the comments below. We're eager to hear your take on this exciting development. So stick around as we continue to explore the world of AI, tackle new challenges, and share the latest innovations. And don't forget to hit that like button and subscribe to our channel to stay updated on all things tech and AI. Thanks for tuning in, and we'll catch you in the next video.